Hello, SINCON. Thank you for taking some time out to join our talk. My name is Steve Boone. If you're hoping to learn a little bit about open source supply chain, the various different modes of protection and the different types of attacks and threats that are prevalent today, get comfortable. You've come to the right place. My name is Steve Boone. I'm the head of product management at Checkmarks, covering a number of different areas, SCA, code bashing, IAST, API security. But today, I want to spend some time with you covering over kind of a newer topic within the world of software security. It's getting a lot of attention when we talk about, and we all hear a lot about, the idea of protecting the supply chain. Today, we want to focus a little bit on the why, what, and how, a little explanation if you're not familiar with supply chain, what it is, what it means, and specifically around the concept of open source, how we can better protect ourselves. We're going to talk a little bit about the concept of confusion, which a lot of these attacks are predicated on the idea of confusing our developers, our end users, our systems. And as we discuss these, we'll step into a couple of different examples. We'll look through 3 different types of attacks that we're seeing that are most prevalent, and then also give you some insight into ways that you can look to protect yourself and your organization from these malicious attacks. So with that being said, let's go ahead. We'll jump right in. Why are we talking about supply chain? Hopefully not a shock to you guys since you're here in this conference. We've seen a number of different supply chain attacks over the last year, and really into 2021, it's just continued to grow. Statistically speaking, this has been the most we've ever seen, and they're anticipating more in the following years. A lot of times when we talk about supply chain attacks, we'll talk about third-party vendors and different systems within our organization that we might consume. But the reality is that when we think about it from an open source perspective, there's even more chances and more threats that we need to be aware of. So there's where we're going to focus on a little bit today. If you're not familiar with the concept of supply chain, it's quite all right. I think everyone can appreciate a refresher at some point in time. We're really going to talk about it today from the perspective of being able to trace where our packages are coming from, knowing and trusting the entity that's there, that we're not being misdirected, misled, that we know that the packages are healthy and safe, that they're coming from a known location. And at the end of the day, what we're really trying to get a peace of mind about is what are the risks associated, what are we setting ourselves up for when we bring in this open source software, and what do we need to know? In general, a supply chain is not a new concept, right? If you're familiar with any type of manufacturing industry, you're probably familiar with some sort of a supply chain. Traditional supply chains, you've got raw materials. Those materials are then brought to some factory or some place where they're assembled. We make good products. We ship them across the globe. We get them into stores and we sell them to our customers. And it's a very similar idea when we talk about it with software. The difference is our raw materials, aren't wood and steel. They're source code, their dependencies, their open source packages. We're using all of those to build together, deploy them across our networks, publish them to our SaaS platforms, and then ideally our customers get the value of the products that we build. And so in that same way, we want to be able to protect all of the different steps throughout that supply chain and have good visibility into where those different raw materials are coming from, and sleep a little easier knowing that they are what we intend them to be. This isn't a new conversation, and I want to share a little bit of a data point with you. This particular one here is some data points from Gartner. And what I like this is from 2017, right? So 5 years ago, we were having and asking the questions with analysts, and they were saying, well, what do you think the risk over the short term and long term? What would you kind of highlight as some of your top concerns? And even back then, that we're pointing at and saying, actually, the security of the overall supply chain is quite alarming. We're putting a lot of trust into open source packages, how they get into our organization. We don't have a lot of control over what packages our developers are using. And in that, in turn, that this whole idea of unknown and trusting gives organizations a lot of heartburn. So it goes without saying, that's why we're seeing a lot of focus on these types of attacks now. It's probably why you're having these conversations within your organization. I'm hoping that's why you're here joining me today to learn a little bit more. Needless to say, the type of supply chain attacks that we've been hearing about are widespread and very damaging. I'm sure you're all probably very familiar with the concept of SolarWinds. And I only bring it up to bring up an idea that we're going to draw a little bit of a line today, and I've mentioned it a few times already. On a lot of these attacks, we're talking about third-party vendors, and I think that term can get a little bit lost in translation. Yes, absolutely, it could be something like the Orion system or other platforms that you're bringing into your organization. But realistically, the much more easier path into your organization are a lot of these open source packages that your developers are using. And the reason that is because today, the majority of the applications that companies are building are largely open source code. Rough estimate here, but when we talk to a lot of our customers, they'll agree with these numbers. They're anywhere between 70 and 80% of the code itself, especially in microservices architecture. We're reusing functionality. We're not trying to reinvent the wheel. There's an emphasis on speed to market, focus on building what you're good at, what you know internally, and then reuse and borrow what you can. And this isn't a trend that is new either, right? Looking back all the way from 2013 even to last year in 2020, just one sliver of an example from Java, right? We're talking about 457 billion downloads of open source components. So this is a trend that's only going to continue to grow. Open source isn't going away, and the pressure that it puts on us and in the importance that it highlights within our supply chain is great. All right, so hopefully, we use that as kind of our short introduction to level set a little bit, and then we can move in to the ideas of some of the attacks themselves. I want to talk a little bit about the idea of confusion. When we start to analyze these attacks, you're going to see a reoccurring theme, which is that these attacks are designed to catch people off guard. It's not that our developers are unsure how to do the job or they're confused about which packages to use. That's not really it at all. But when you hear these terms confusion, especially associated with this tax, really what I believe it boils down to is the fact that there are a number of responsibilities that we're putting on our developers today. And with newer modern architectures, microservices development, they're really burdening everything from not only writing the code, testing the code, deploying the code, but being the first line of defense for, whether it be customer support, any kind of security issues that crop up, production issues, they're taking it all on. And so in this, grand scheme of wanting to shift everything left, it becomes very easy to overlook certain aspects and to make sure you're dotting all the I's and crossing all the T's from an open source security perspective. And because of this, we'll look at a lot of the different types of attacks that we'll talk about. Confusion's definitely there, but there's absolutely this element of misdirection, right? I love this quote, what the eyes see and the ears hear, the mind believes. And so we put a lot of trust into our architecture, into our CI and CD tools to be intelligent enough to know what packages to go grab, where to grab them from. And, it's one of those things where it's like, if it's not a problem, it's not broke, don't fix it. But more and more, it's that kind of trust that we're putting into these systems that we're essentially being called out for and that malicious attackers are taking advantage of. So with that being said, and keep that in the back of your mind, we'll jump into a couple of different types of these attacks, explain a little bit about how they operate. We'll start relatively easy and simplistic, and then we'll work up to some more complex examples as we go. All right, so let's start with the first one. I want to talk to you about the idea of typosquatting. Now, this shouldn't be a new concept to you. I imagine that you've experienced typosquatting yourself, whether you knew it or not. Usually as you're trying to go browse your favorite websites, you might make a mistype and end up at a completely different website. Even be surprised that that typo actually found a registered and served up page itself instead of just throwing up some exception. Those types of circumstances, those types of events are known as typosquatting. And we got this great graphic here that we borrowed from our friends at Anomaly. But I like it because it talks about a couple of the different techniques that we see in typosquatting, things like switching letters, typing the wrong keys, using, let's say, letters or capitalization that look similar, occasionally doubling characters. All of those are different methods in which we see in open source packages. When you're going out there, especially if you're a developer and you're running from the command line, you're trying to pull down some of these packages, it's really easy to make these kind of mistakes. And malicious actors are putting out there inappropriate, I'd say packages that are not only malicious, but are named this way to get you to make that mistake and get you to pull those packages into your own environment. So specifically, some examples that we see, right? Combo squatting, as it's called, is quite popular. If you look at, the idea of combo squatting is we're essentially just appending a different set or word or character onto the original package name. So, a common one you might have is Lodash. Lodash S is, something that I know I myself have typed even inadvertently at times. dflow, and looking like something that would seem very appropriate. dflow node, sure, why not? I'm a node developer, that makes sense. That's probably what I want. But nonetheless, those are not the correct package names. A mission is quite popular as well. So common package we might look for, cross dash or hyphen env, simply just removing that. Another thing where, as a developer, as you're thinking about all the different packages that I need to maintain in my manifest file or anything that I'm trying to pull down in a dev environment, it's easy to miss. Right? Repetition, things like, in this case, adding a second letter to a package name, like jQuery with 2 R's. In another one that's common, transposition, taking the package electron and turning it into electorn, where you're simply just switching or transposing those 2 letters of the package name, are also quite common. And this seems like something that you would be able to sit back and go, okay, what's the real threat here? And in fact, we've been able to go out and find a couple of hundreds of different packages where this is actually out there, and people are looking to pull those down. And as we find them, from a research perspective, obviously we're reporting those back to the package managers, doing our best as good stewards of the industry to get them cleaned up. But it's something that you should be aware of, right? And at the very least, we need to educate our developers to be knowing what to look for when they're interacting with these packages. Some different ways that you yourself can think about protecting yourself from types of typosquatting. First and foremost, I'll say any package manager site you go to should have an installation command for that package right there on the screen. And it's easy enough, sometimes even available through endpoints that you can call from an automation perspective, but also the old method of copy and paste works quite well, of just making sure that you're absolutely getting the package that you want, you're pulling it with a known installation, and you don't have to worry about some of these what seem to be silly or oftentimes foolish mistakes. Another great way to go, and probably from a more scalable automated perspective, is to invest in a good SCA style of tool, software composition analysis, something that's going to be able to scan your open source packages and at least give you some visibility into what packages you have. These tools are looking for known entities. So when they stumble across something that is misnamed, it's easier for them to call out and say, hey, we didn't find this package in the package repo. And it definitely doesn't have, the same hash that we would expect to be for other files. And so that is one way in which some of these tools are smart enough to recognize these malicious packages, ideally identify them for you, so you can get them out of your environment before they get included in any of your incremental builds throughout your agile development process. All right, so we talked a little bit about kind of phase 1, some low-hanging fruit in typosquatting, but let's get into a little bit more of a complex scenario where we'll talk about dependency confusion. This is one that has become extremely popular. There's a lot of great blog posts out there around dependency confusion, different ways that companies are protecting themselves from it. But I would like to take this time to explain to you, maybe you're not absolutely familiar with how dependency confusion works, what it looks like, and the different implications of it. So let's start with this image here. Many organizations will make use of an internal repository for hosting libraries with the whole goal of making sure that we would then know where those packages are coming from, right? And we know that they're coming from a known, safe location. In an ideal world, this would be good. This would be enough. We wouldn't have to worry about any, quote-unquote confusion. And the expected outcome from this scenario is that during your your CI/CD process, right, as part of your build, we're going to grab the appropriate packages from the appropriate location. So in this example here, we're grabbing Flask and Angular from public repos, and then we might look into our manifest and see, hey, there are specific company packages that are specific to our organization, and we're grabbing those from the private repos, right? We pull all that down, we do the compilation, we build it, we put it out there. Everybody feels good about the process. So this is the expected scenario, and probably something that you're doing within your organization and have been doing for some time, right? This isn't definitely by any means a new type of process. What's interesting about dependency confusion is there's kind of a broad scale and there's a very narrow scale to this type of an attack. On a broader scale, I might not necessarily just go and focus on your company infra, right? I might actually look at just saying, hey, I'm going to raise the version number arbitrarily of some known entity package that's a public package, and hope that you pull that down. Hopefully that, or hope that your package manager gets confused, grabs the wrong version. So that is one way they can do this. But a much more malicious attack and a much more focused attack, which we're seeing more and more of, is hackers actually taking the time using crawlers, looking into some of the various different files to try to find specific information about your internal packages. And how this happens is, especially for companies that contribute back to open source, in any of their package.json files or other files where they have dependencies labeled out, they clearly have listed some internal package names. And this gives an attacker the appropriate way to know what to name those packages to hopefully confuse your internal systems. So let's take a look for a second and see a little bit of how that works. So in a situation where we're kind of in, let's say, an under attack situation, you've got hackers publishing malicious code, publishing packages. As I mentioned, they're going to use the same name of an internally named package, but they're going to boost that version number up. And what that means is as we're going to check for the latest version, it's going to go, oh, wait a minute, I noticed that there is a newer, higher version of this, newer being the imposed or confused word there, that we want to go grab from another location. In other terms, don't go grab it from my internal repository. And this type of attack is expecting that you have these things configured inappropriately, that for all of the different development teams and all of the different internal repos that you have, somewhere along the way, someone has it configured to the point where it will allow them to pull these packages from the internet. In these scenarios where we're allowed to pull packages from both private and public repositories, this is really based on logic that says external first, right? And that shouldn't be something that we configure. It's actually one of the things that will advise you against. We always want to be looking internally first. And so in these scenarios, as we're doing the build and the compilation, these things are going out, they're pulling down the wrong versions, and next thing you know, you've got the malicious package into your own environment. And as I mentioned, right, and if you look at kind of the deeper details here, here's an example from one of the blog posts out there, specifically on public packages that PayPal is using, where you can see within these files themselves, they are listing out the names of those internal packages. And so those are the things that you really want to be aware of. And you have to ask yourself, as a company, if we're contributing code back to the open source community, are we doing the due diligence to track our steps, make sure that we're not oversharing information, and then also letting people aware of kind of the internal package names that we're using? There are some very deliberate things that you can do as an organization to help protect yourself in these areas. One of the things you can do is that if you know you have some internal package names and you know for a fact that you're contributing back to open source, it would behoove you and be very wise to actually go and register those relevant package names within those package managers. That way, even if somebody wanted to and they discovered those files, those names are already registered and you own them and you're under control of them. Part of that is knowing which of your packages might be susceptible to these types of attacks. I think you'll have an easier time knowing that if you are certain which projects you're contributing back to for open source. I would start there. Any of the projects that consume those open source libraries could be the potential ones that you'll want to identify. The other way you can do it is you can always take a trick out of the hacker's book themselves, which is to crawl these repos and look within them for your own internal names. That is something that is more proactive, but if you actually do the effort to write the crawler, you can continuously run it and kind of monitor that from your own end. Companies have been getting very hip to the idea of dependency confusion. I'll talk about Twilio for a second because I think they had a great blog post out there where they've done some really cool stuff in explaining what they've done to protect themselves from dependency confusion attacks. Some of the things that they highlight here, they introduced and enforced naming conventions for all internal packages published and consumed in Twilio. And that's important because it makes it easy to identify. There's a standardization there that helps raise the bar from a safety perspective. They went ahead and blocked the proxying of all external packages. And so in that case, if anything collides with that specified naming convention, they don't have to worry about it. They're not going to be pulling it down. The other thing that was really cool, if you read through their posts, is they talk about they always serve internally first, right? And I think that's key. And when we look at exactly how a lot of these dependency confusion attacks are even possible, it's predicated on the fact that you do have things configured wrong. So looking internally first is going to be key. And then they also took it even a step farther and said that kind of a mandate that all package installs that come through their internal package manager proxies, all mandated packages need to come through their internal package manager through a proxy. So even things that might be potentially coming in from the outside are going to be sanitized, looked, and reviewed before they get put into their own internal repo for developers to consume that. So it feels maybe a bit heavy-handed to say, well, wow, we really got to put all these extra steps in place. But that's where we are in today's game. There is no other way to really protect yourself other than taking this kind of zero trust approach and putting some of these very concrete guidelines and blockers in place. All right, so we talked about typo squatting. We've talked about dependency confusion. I want to talk to you about another one, which we call chain jacking, or also commonly referred to as repository jacking. And this is, again, based on something that is intended to be a good feature in some tools that we all most likely use on a pretty common basis. So we'll walk you through this. What we're looking at here is a post from 2013 from GitHub out on their blog where they talk about repository redirects and explain to you, very excitedly, that there are some good things about repository redirects and why would we have redirects. And they really call out three scenarios. They say, when you rename your repository, if you rename your organization's users' accounts, or if you transfer a repository to another user or organization, that's when you will experience redirects. And in theory, this is extremely helpful. Most people embrace it. But these back doors are essentially created by redirects. And what happens is all somebody needs to do is take that original account or account name that you had and reestablish it for themselves. So we'll talk a little bit about what that means and what that looks like. When you go to change a name of your repository within GitHub, you get this nice warning letting you know of some of the unexpected bad things that could happen. And they call out the fact that they're not going to set up redirects for your old profile page, and they're not going to set up redirects for your page's sites, but they will create redirects for your repositories with both web and Git access. What they fail to mention is kind of the very important thing, which is that after you change this username, it's available to anybody who might want to go out and claim it. So if I decided to change my username account, you could go out there and create a new one with my old name. And that has very serious implications. And we'll talk about what exactly that looks like. So, internally at Checkmarks, we've been doing the research on chain jacking now for quite some time. We've analyzed almost 500,000 projects. We found a number of vulnerable packages where this is we've seen this happen at, where people believe that they're accessing one repository when actually they're being redirected to something completely different. And it's happened on some quite popular projects as well. You know, anything ranging from small projects with maybe only a couple of stars to things that have well over 1,000 stars. So it's not just random smaller packages that are being affected by this. We're seeing it happen all over. And so I want to walk you guys through kind of this transitive nature of how one can take over these packages and what it might look like in a real world scenario. All right. So first and foremost, let's kind of step through it one by one. In our first scenario, we've got an idea, individual user, we'll call him John Doe. He goes to GitHub, he creates his account, everything's great, and he creates a brand new repo. In this case, he calls it PizzaLib, right? So he can go to GitHub/JohnDoe/PizzaLib, and everything works as would be expected. That library can be consumed both directly and transitively. Other folks can go out there and consume it, pull it down. Everything's great. Everybody's happy. So far, so good. Let's say that John Doe then all of a sudden goes and decides, you know what, I'm going to go ahead and change the name of my repository. No longer needed to be that. We're getting quite popular. I'm going to change my name of my package to Alfredo because it's Alfredo's Pizza, let's say. The functionality for the redirect will be preserved, right? If you were pulling down PizzaLib previously, anything that you have in your manifest will look out, or will make that call, and GitHub will do the work for you. It'll say, oh, you wanted PizzaLib from John Doe? It's actually PizzaLib by Alfredo now, and we'll make that redirect. Therefore, we'll keep everything whole for you. You won't have any interruption to your build process. Everybody goes off and everybody's happy. The real challenge comes from when we get into this idea of somebody actually taking and repurposing this original John Doe username. So a new person, let's say an attacker, comes by, he recognizes that this has been done, he re-registers, registers a new account under that same John Doe username. And so now he owns the GitHub/JohnDoe/PizzaLib. And this is where he can create that same PizzaLib library. He can put whatever kind of code he wants in it, most likely malicious. And then at that point, when we go and your files are now looking to pull down and do that redirect, it's not going out and finding Alfredo, it's going out and finding the new John Doe, right? And in that scenario, this is where the attacker can easily get that malicious code into your organization. So it is a subtle attack. Again, it's not something even that you can really go to and say, well, hey, this is broken, it shouldn't work like this. It's actually working as designed. The redirects are doing everything that they intend them to do. Ways that we can start to protect ourselves from some of these things. Really kind of two key takeaways here. One is package owners. First and foremost, we should try to avoid renaming whenever we can. That being said, as GitHub calls out, there are times where that might make sense and you might want to do that. If you find yourself in that situation, the best thing that you can do is hang on to that old username. Make sure that you still maintain that account. Don't leave it out and floating in the ether for other people to come and pick up, because you'll find yourself the prime target for one of these chain jacking or repository jacking style attacks. Okay? So I want to thank you guys again for spending some time with me today. I hope that you found at least an overview of the open source supply chain attacks beneficial. From a checkmarks perspective, we've got a lot of cool things coming up. We're going to have an ebook that we'll be publishing out specifically on open source supply chain attacks. These types of attacks plus more will be in that ebook, with other ways that you can work to improve your own process or own organization's processes. We've got a number of good webinars and blogs out there on this topic. If you have any questions, if you'd like to say hey, please feel free to reach out to me on LinkedIn. Again, Steve Boone. I want to thank you guys so much. I really do appreciate your time. I know it's very valuable, and I hope you enjoy the rest of the SINCON conference. And with that, have a great day.